and welcome back, natural disaster students. We're going to start transitioning into some of our more weather-related disasters. So I want to do a real quick intro to some basic things about weather that are going to help us understand some bits about storms and things like that. So that's what we're going to do today. And like I said, we're going to hit some of the highlights here, skip through some of the rest of the material, but again, make sure you go through all of this. So what I want to start with here is actually slide number 4. And really talk about the importance of rising air and high pressure and low pressure and things like that. So basically we have what are called high pressure and low pressure systems. High pressure is when air is sinking towards the surface and creates a higher pressure, pushes more on the ground. Low pressure when air is rising away from the ground and creates less pressure. And you notice on the diagram here, you'll see that there are clouds associated with the low pressure. We don't have clouds associated with high pressure. And that's what we want to associate, right? That's the correct association. When air rises, its temperature drops, it cools, it gets to the dew point. That's the point at which the air can condense from a gas, or I should say the water can condense from a gas to a liquid, and that forms clouds. When you see clouds, what you're visibly seeing there are liquid water droplets. So you've condensed from a gas to a liquid. So rising air is a way that we can get clouds forming. So when we start talking about weather-related disasters, rising air is a critical part of that. So getting air to rise up is immensely important when it comes to, again, storms and things like that. Let me just jump to number 6 here. So if rising air is important because it's an important way to get clouds, then we know that once we get those forming, we have then the potential for, again, floods and hurricanes and tornadoes, and even worse, sharknadoes. But if rising air is important, let's understand a little bit about how we can get air to rise up. One way is what's called orographic lifting, which is when we force air to rise up along mountain ranges. So sometimes we'll see clouds more up in the mountains than we will in the valleys. Some pictures of that here. Another way is from what we call frontal wedging. This is just along fronts. Cold fronts and warm fronts are two common fronts that we have that lift air up. And so that's a common way to lift air, again, along cold fronts and warm fronts. And then convective heating. This is where we get uneven heating along the Earth's surface. So we get little pockets of less dense, warm air that wants to rise up. And as it rises, it cools, condenses, and eventually forms clouds. And we can get thunderstorms and things like that from that as well. So a variety of ways that we can get air to rise. And again, that rising air is important because it can, again, eventually lead to clouds and storms and things like that. All right, slide 14 here real quick. This is just looking at the different layers of the atmosphere. This is based on the temperature profile. So the red line here shows you temperature, our scale for temperatures down here. We have height here in miles, height here in kilometers. And so you'll notice temperature decreases, stays the same, increases, stays the same, decreases. So basically kind of zigzagging back and forth, which is kind of interesting. Most people think that the temperature just decreases straight as you go through the atmosphere. It actually does not. Depends on where you're at in the atmosphere. But these zigs and zags are the boundaries for different layers of the atmosphere. The bottom layer is what we call the troposphere. The layer above that is called the stratosphere. The layer above that is called the mesosphere. And the layer above that is called the thermosphere. Now, so those are just the different layer names. I will say, for our purposes, the most important one we're going to deal with is the troposphere. As far as the weather is concerned and the weather-related disasters that we are talking about, they all take place down here in the troposphere. So all the weather, all the disasters, etc., down here, troposphere. Not that these aren't important, but as far as our class is concerned, really it's the troposphere is what we're going to focus most of our efforts on in terms of understanding. Now, a couple other things I want to mention here real quick. Just again, weather basics. I want to mention El Nino. El Nino is a temporary, naturally occurring climate change that we have that takes place. It starts with a weakening of what are called the trade winds, and it sort of wreaks havoc with ocean currents. And what it does is it basically kind of reverses some of the basic ocean currents along the equator. And the end result for us here in Southern California is it brings much warmer ocean water, and as a result, much more storms to California. That's during El Nino. Normally, we have cold water and fewer storms. That's what we call La Nina. So El Nino is this naturally occurring temporary climate change, occurs on average about every 4 to 7 years. Some years it's really weak, some years it's really strong. Just depends on the year. The last big one we had was 2017, 2018, right around there. We had a very strong El Nino, but it went a bit north of us. We got maybe a little bit more rain than normal here, but not much. But during a good, strong El Nino that impacts Southern California, we will have, in some cases, 2.5 times the normal amount of rain that we would normally have in a given year. So it can get quite wet during El Ninos, and that leads to an increase in flooding, increase in mass wasting processes, debris flows, mud flows, landslides, things like that. So it leads to a lot of problems that can occur with that. And then real quick, I did want to mention just climate change, human-induced climate change, and what we as humans do to unfortunately change our climate. And what we do is we produce a lot of carbon dioxide through the burning of fossil fuels, basically gasoline, coal, oil, things like that, natural gas. Part of the byproduct of burning those is carbon dioxide. What carbon dioxide does in the atmosphere is it lets, simplifying this, it lets sunlight through but traps heat from going back out, or it slows it down from going back out to space. And so in essence you have more energy coming into the Earth than is going back out to space. That causes temperature to increase. So it creates an imbalance in the energy budget on the Earth's surface. How does that affect disasters? Well, as the climate changes, we expect, and we see this in the modeling and in reality, is we get what's called a climate weirding. The climate gets weirder, or a better way to explain it is it's getting more extreme. What we expect to happen and what we see happening is more extreme variations in our climates, so that the floods are getting worse, the droughts are getting worse. So we should expect to see changes in things like flood frequency and intensity, hurricane intensity and frequency, droughts, their intensity, their length, things like that. Tornadoes, we don't quite know yet. That if there is a change in tornadoes, it's not quite obvious yet, so the jury's out on whether climate change is affecting tornadoes, but it certainly appears to be having an influence, certainly in things like droughts, hurricanes, and floods. So it definitely has an impact on our natural disasters. So that is a quick summary of some weather basics to help us understand some of the basics about the atmosphere as we go forward and talk about severe weather, tornadoes, and ultimately hurricanes. And fires. We should mention fires as well. So, all right, so if you have any questions, let me know. Otherwise, until next time, stay safe, guys.